We've previously seen how indexing and slicing works with Pandas DataFrames and Series. Filtering is a more general tool for selecting part of the data, not based on labels or positions, but based on properties of interest of the data in itself. DataFrames have several special methods for filtering. Underlying filtering is the idea of a Boolean series. Here, we ask where in the sort series is the number of sales recorded greater than 60. The series returned has true or false values according to whether the salt sold in that particular month was more than 60 units. In itself, a Boolean series isn't that useful, but when it is used to select from a series or data frame or array, it is very powerful. When used to make a selection, a Boolean series is called a filter. A filter may be used directly between brackets as a logical expression, or it may be assigned to another variable. In this case, the explainer variable enough salt sold. Filters can be combined using standard logical operators like and, or, and not. Here, we combine the filter salt bigger than or equal to 50 with the filter eggs strictly less than 200, first using and, so both have to be true, second using or, so either can be true. Notice the use of parentheses to enforce order of logical operations. Missing values are commonly encountered in data analysis. These missing values are sometimes represented by zeros, at other times by the special nan, not a number value. Here, let's copy our data frame and add a column bacon with some zero elements. We'll use this new data frame, df2, to explore Pandas methods for selecting or excluding data slices with zeros or nans. For instance, we might ask which columns have all non-zero values with the method all. This selection excludes the bacon column because it has 0 entries. We might also ask which columns have any non-zero entries. In this case, there are no columns of all zeros, so all of df2 is returned. A related question is which rows or columns contain nan. We can ask that with isNull and notNull. Combining any and isNull returns any columns that have a nan value. Conversely, we might want all columns where all data is present, that is, there are no nan values. We can combine all and notNull to get this from the original data frame df. We can also remove rows with missing data using drop NA. Using how equals any, the row may is dropped from df because it does have a nan entry. By contrast, how equals all would keep this row. Filtering can be powerful when used to assign values. We might select the egg sales for those months in which the salt sales are high. Explicitly, we extract the eggs column from df and filter the indices where the corresponding entry of the salt column is larger than 55. The result is a series subselected from the eggs column. This filtering allows us to calculate one column based on another, in whole or in part. Based on a filter on one column, we can modify the value in another column. For example, perhaps with every large salt sale, a few eggs are thrown in for free. It's your turn now to practice using filters with Pandas Series and data frames in the exercises.